Hello, my name is Esteban Flores, and today we're going to be demonstrating a calculator. So very quickly, let's go over base conversions. So here we have our normal decimal values, which is going to be from 0 to 15, and I included 16 just for reference. But mainly here in this project, we're going to be going over binary and hex. Binary, we're going to use 4 bits for our switches, and we're going to use hex to represent numbers in our 7-segment displays. So here we have an example of a 4-bit adder. We can see that here we represent our numbers that we want to add in decimal, so 4 and 3. And when we add them together, we're going to get 7 in decimal. Now we got to convert these into binary over here and do basic addition. Here, when we add these two numbers together, we get 1, same with this, and same with this. So we should get 3 ones down here. And for our last row here, both zeros, when they add together, we're going to get 0. Here in the top, I was also sure to annotate all the carries. We can see that I highlighted these two numbers here, the carry out and the carry 3. And this is important because in order to detect overflow, we got to exclusive OR the two. So because carry 3 is equal to 0 and carry out is equal to 0, when you exclusive OR them together, the output is 0, which means that the sum of these two numbers won't trigger an overflow. So now let's show you guys a demonstration on an FPGA board. So here on our 7-segment displays, we could observe that we have the numbers 4 and 3 here. When we add them together, we get 7. And we could also see that we can modify the numbers that we put in with the switches. So there's switches between 3 and 0, which represents 4 bits. And these are switches 7 to 4, which also represents 4 bits. And the FPGA does the logic to make the output. We also include a 9th switch, or switch number 8, which is going to be our carry in input. And what it does is that it adds an extra digit into the adder system. So when we switch it up, we can see that we're going to increase it by 1, which should go to 8. Now, we could also observe that there's a little symbol right here that I created to denote that we are triggering an overflow. So let's go ahead and explain overflow for a second. So we could see here in this example that we are adding 4 and 4 together, which should get us 8. And here, when we're doing the binary summation, when we add 1 and 1, we should put a 0 here and put a 1 in the carry. And that carry goes all the way down here, and we won't have a carry out. When we have two different numbers in our carry out and our carry 3, it should trigger our overflow. Reason being is because when we exclusive OR them together with the 1 and the 0, it will equal 1. So we could take that number and represent it in our 7-segment display. Overflow is important when we are discussing signed numbers. When we observe the most significant bit to be 0, that means that these 3 numbers are going to be representing a positive number. If the most significant bit is 1, it's going to be representing a negative number. So these 3 numbers here will be our integer. And here is just going to tell us if it's going to be positive or negative. And again, it just needs to be 0 or 1. It's also important to show the formula of how many digits we can represent in a signed number. So here for 4 bits, we could only go from -8 to 7. So going back to our FPGA, we can see here that when we cross the number 7, we're going to be getting overflow. And again, we discussed the range of it only being from -8 to 7. So here on our 7-segment display, we can see that when we add 4 and 4 together, we get 8, which is past the range of our 4-bit signed number. And again, we're going to get the overflow here because this isn't the true number we wish to display if we are using signed bits. This is the highest number I could display before I need to flip the most significant bit or the 4th bit on any one of these. In which case, let me just turn this off really quick and then I turn this on. We will see that the overflow display doesn't turn on. Anyways, I hope you liked this video. This was a really cool project to work on and I really enjoyed demonstrating this for you. Have a good one.